5, solving polynomial equations, and advanced factoring. I think that's really what gets people. That's how we're going to solve polynomial functions, by advanced factoring. Anyway, our first advanced factoring is the sum of cubes. So we already had the difference of cubes, which is the squares, it should say, where you get a minus b, a plus b. Right, when the first term is taken, when both terms are squared, you could factor it out like this. Well, same idea. If you only have two terms and they're both cubed, you actually can factor both, plus and minus. And it goes into this case right here. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. How to remember this? Well, it's always the same. It's a different one, and it's positive or plus. Now, honestly, I'm gonna give you the formulas, but that's a good way to memorize each one. So again, this only works when they're binomial terms. So just like over here, if it's a binomial term, you can do this. So now that adds to our little like polynomials, right? Anytime. First step always. Step 1 is always factor out the GCF, see if they have anything common. And then it's all about what type of polynomial do you have. Do you have two terms? Then it's either a difference of squares or it's a difference of cubes. Remember, if it's not one of these, then it might be a prime polynomial. And when you can't factor, it's prime. If it's three things, you can do it the fancy way, or you can do a shortcut way, if it has no number in front. And if it's 4 or more, and what we do is by grouping. So anytime it's more than 4, grouping is the way we've got to go. Okay, so let's do a couple by grouping first, actually. Look at this. There's 6 things here. We're still going to group the same way. If you look at the first ones here, the first 3, it's cut in half. They all have an a in common. You're left with 3x plus 2y minus z. Now look at the next 2. They all have a b in common. So, oops, sorry. b 3x plus 2y minus z. And now, hey, these match. 3x plus 2y minus z, and look what's left over, a plus b. So that's how you factor it by grouping. That's one way to factor by grouping, actually. There's another way you can do it too. You actually do it. You could do it. You could pair them up. If you rearrange it, you could pair them up. Yeah, let's like do it like this, so you can see it. Put everything with the 3 together, everything with the 2 together, and everything without the negative 1 together. In this case, you could factor out a 3x, you get a plus b. And over here you can factor out a 2y and get a plus b. And over here you can factor out a negative z and get a plus b. And if you notice, these all match. So you get a plus b and left over 3x plus 2y minus z. So 2 ways to do it. I think most people like to cut it in half. Just do it that way, but it's more than one way to skin a cat. So anyway, next one. Same thing here. So now remember, you always want to make sure if you can do, you might have to rearrange it. So like, let's look at all the x's. Oh, the first 3 all have an x, so let's just do it that way then. X, and you get 2k plus 4m all. I can also factor out a 2. So 2x k plus 2m minus z n minus n. I can do math. Over here, they all have a 3y in common. So remember, always bring on the middle sign. Divide that by negative 3, you're going to just get k. Divide that by negative 3, you're going to get 2m. Divide that by negative 3, you get a negative n. It's supposed to be an n. These match, you know they look ugly, and you get k plus 2m minus n times 2x minus 3y. So you get that. So that's how you factor by grouping, right? So again, you can break it in half, or you can do pairwise, either way you want to do it. Now let's look into factoring the difference of cubes. Let me put the formula right here so we could use it again. Now the rules are a cubed minus b cubed is same, different, plus. And if it's a cubed plus b cubed, it's same, different, plus. So that's the formula. I will give it to you. I just gotta know how to use it. So remember, this only works when they're both cubes. So let's do this one first. And actually, don't forget the first rule of this one, of factoring, right? factor out of GCF, factor out anything they have in common. In this case, it makes your life so much easier. In this case, they all have a 2, so I'm factor out a 2. So I get 8g plus h cubed. Now if you look at it, 8's a cubed, and g's a cube, and h is a cube. Right, so I'm going to rewrite it real quick so you can see it. Like, because again, this only factors if they're both cubes. So this is like saying 2g cubed, and it's like saying h cubed. And there's a 2 on the outside. Why do I write like that? Because all we got to do is, once you understand what the a and the b are, that's what this is. This is a, and this is b. All you do is plug it into the formula. In this case, plug into this formula. So it's going to be 2g plus h. Now, a squared, I got to square this. So that's, remember, if you square 2g, you square both of them. So it's actually 4g squared, right? That 2 goes to both. Okay. So 4g squared minus a times b. So I got to multiply these. So 2gh plus h squared. And on the outside, don't forget the 2. So that's how you factor that one using difference of cubes. Now let's go back to number 3. If you look at 3, they have nothing in common. 2 is not a cube and 5 is not a cube. So I can't do anything. This is prime. And the next one, they do have stuff in common. They both have a p and a q, a 12 and a q. So you factor it out first. Put w cubed minus q3. And now look at, they're both obviously primes. This will be my a, this will be my b. And just following the formula, it's same, same, opposites, and then positive. That's supposed to be WQ. And there's a 12Q on the outside. So it looks like this. Look at that. It's another factor by grouping. We're going to skip that one because we did a lot of these. It's a lot of factoring ones. We're not going to do all of these. This would have an x squared in common. We'll factor out. This would be a6 minus b6. And that actually is a cube. This is the same thing as saying a squared cubed minus b squared cubed. Alright, so that's a tough one because it's like, it is a cube, but it's not the normal cube. Just be my a, my b, so I'd get same, and then you gotta square it, so it'll be a to the 4th, opposite, so a squared, b squared, and positive, and it's that one squared. And don't forget the x squared in front, so that's a funky one. That's another, we'll skip all the factor by grouping, those are easier ones. Let's do one more of these. So this one, they have nothing in common, but these are cubes. It's the same thing as saying 2c cubed, and that's 5d cubed, right? So it's all about figuring out if they are cubes, and then you can write it like this, and then this is your a, this is your b, and the formula is this, and this, right? Same, squared, different, positive. So it would be 2c minus 5d. Then you got to square it. 2c squared is 4c squared plus, multiply them together. So 10cd plus 5d squared, which is 25d squared. And that's how you factor. But that's how you do difference of cubes, right? Make sure they're both cubed. And that's the hardest part. Once you figure out they're cubes, then you just follow the formula. Okay, so next part is actually a very important concept, and it's called quadratic form. So the idea is this. We know how to factor if I gave something like x squared plus 5x plus 4. You'd be like, oh, it's x plus 4, x plus 4, x plus 1. The idea behind the quadratic form, it works the same no matter what the powers are, as long as the middle one is half of the first power. In this case, as long as the middle power is half of the first power, then you can factor it the same way as always. It's always the middle one, and whatever these things are. That's quadratic form. As long as this one is half of that one, you're good. So if I gave you stuff like x to the 10 plus 5x to the 5th plus 4, this is half of that, so if I make it x5, it'll work because x to the 5th times x to the 5th is x to the 10. It all kind of follows. So that's quadratic form. If the middle term is half the first degree, the leading degree, then you could factor it like normal. That's what quadratic form is. So this first part just wants to know are these in quadratic form, yes or no? Well, look at this one. That is half of that, so yes, that's quadratic form. I can in theory factor this. It'll be like x cubed and x cubed. This one, no, it's not. This is not half of that, so no, right? There's no way I can multiply two things, the same thing twice to get that. So that's quadratic form. Now let's use it to solve some problems. Again, notice how this is half of that, so I can just factor like normal. It's going to be x squared. Now I just got to figure out what two things multiply to get 48 but add to get negative 19. And that is not 4 and 12, it's 18 and 3, 16 and 3. 16 and 3, yeah, so 16 and 3. 16 times 3 is 48, add me get 19, so there you go. So you have this, so you factor like normal, and I could split it like we always do. X squared minus 16 equals 0. X squared minus 3 equals 0. Remember, if you only have one term, one variable, just solve for it. X squared, you could factor, but easiest to solve for it. Square root it, and remember when you square root it, you should get plus and minus 4. And over here, x squared equals 3, square root it, x equals plus and minus rad 3. One thing I want to point out, notice we have 4 answers, and they start off with x to the 4th. That's called the fundamental theorem of algebra. That should always be the case. Whatever the highest power is, that's how many solutions you should have. So I should have 4 solutions. Let's move on to the next one. So this is why I bring this up. So if you first notice, you could graph it, right? I mean, so you could solve for it. There's only one variable, solve for it. And then you cube root it. X equals 4, and like done. Except for one thing. There's only one answer here. I should have 3 answers. So what happens here? In this case, since it's an odd function, you have to factor it. I gotta find my 3 solutions. I only got 2 solutions. That's not gonna cut it. So we gotta factor it. Luckily for us, it's a difference of cubes. This is x cubed minus 4 cubed. So I could factor it as in same, different, you multiply them, a and b, plus b squared. So 16 equals 0. Just using the formula. I've done a lot of the minus ones. It should have been a and b. A plus b to a minus b. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. Again, I will give the formula every single time. Now we got to solve this. Well, one of them's easy. X equals 4, the one we found. All good. This one right here, not so easy. Because I got news for you. This one's never factorable. It's never going to work. So we have to solve it either using, the only 2 ways that always work, and that's either compute the square or quadratic formula. So you can compute the square on this or use the quadratic formula. Both of them are actually equally not bad on this one. I'm going to do quadratic formula because I think it's one that most people prefer. So it'll be a, b, c. X equals negative b plus or minus b squared minus 4ac all over 2 times a. So 16 minus that's 64. So I get negative 4 plus or minus negative 48 all over 2. So I'm going to get negative 4 plus or minus, and remember there's a negative, so if you pull it out and make it an I. Rad 48 over 2. I can break down 48. What is that? 12 times 4. And that is 4 times 3. So pair of 4s. So negative 4 plus or minus 4i rad 3 all over 2. And I can reduce that a little bit. They all divide by 2. Whew. Negative 2 plus or minus 2i rad 3. Right, those are my 3 answers. 1, 2, 3. Right, so it gets, solving the cube ones are actually the worst. Because you're like, oh, I got to factor it. And that's not going to factor pretty. Same would happen with the next one. Right, if I was going to factor this, again, I'm not going to solve it because I know I should have to have 3 answers. So I'm going to factor this. This is 3 cubed. So it's going to be x plus 3. X, this is the formula. X squared, same, opposite, minus 3x. You just multiply them. Plus 9. Again, if you're not sure, I just use the formula. That's all I did. You'll have it. Just got to use it. And then when you solve this part solves easily. X plus 3 equals 0. So x equals negative 3. This part, either quadratic formula or compute the square. And this one right here would be quadratic formula because compute the square is ugly on this one. So you do this because it's not even. And you get 3 squared minus 4 times 1 times 9 all over through 2a, so 2 times 1, my mistake. You get 3 plus or minus, what is that, 9 minus 36? 9 minus 36 is what, 27? So 3 plus or minus cube root of 27, negative 27. And that's the same thing as saying 3 times 9. So that's going to be 3 rad 3. So you get that, right? Those are my 3 answers. 1, 2, 3. Yeah, not pretty. Those are not pretty, but that's how you do them. Let's get to some of the easier ones. I'll skip down because of space. Let's go to this one. Now again, these are, when you see this like this, all you care about is to see if the middle one's half of the first one. You're like, oh yes it is, I can factor like normal, right? It's just it's in that form. So you just factor like normal. So it's always the middle one here, x squared. Find two things that multiply to get 8, add to get 6. So that'll be negative 4 and 2. So much easier than the last ones. Split it. X squared minus 2 equals 0. X squared equals 2. Square root it. X equals plus and minus rad 2. X squared minus 4 equals 0. X squared equals 4. X equals plus and minus 2. Again, notice 4 answers. 1, 2, 3, 4. X to the 4th. It has to work out that way. Now this one, same thing. I can do it real quick, right? Half of that, so y squared. Y squared. Two things that multiply get 17, but I have to get 18. What is that? 12 and 6. Minus 12 minus 6 equals 0. Split it. Y squared minus 12 equals 0. Y squared equals 12. Square root it. Plus and minus rad 12, you gotta break that down though. 3 and 4. Square root of 4 is 2. So 2 plus, plus and minus 2 rad 3. Y squared minus 6 equals 0. Y squared equals 6. Square root it. Y equals plus and minus rad 6. Can't break that down. So that's how you solve it, right? So that's solving things in quadratic form, right? Not that bad, just factor like normal. It's kind of ugly when it's only cubes because you have to factor it, and then that side does not factor nicely, so you use quadratic formula. Doable, but just kind of ugly. Okay, let's move on to the next thing. Let's do an application problem or two. Let's see this in Boardwalk. Let's set this one up, but we won't solve all the way. So the pond is 30 feet wide and 40 feet long. So like 30 feet wide, 40 feet long. The combined area of the pond and the boardwalk is 2,000 square feet. So remember, the area would be this whole thing. The way we set that up, this would be 30 plus the width of the pond twice. It's 30 plus 2x. The same thing with this one right here. This would be 40 plus the width of the pond twice. So 40 plus 2x. So we know the whole thing is 2,000. So it would be 40 plus 2x times 30 plus 2x equals 2,000. And they would want me to set this equal to, multiply it out and set it equal to 0 and factor. I personally would just use my calculator, y1, y2. Because that's going to be a lot of work for no reason. Let's do it. Let's do it. I'm going to show you guys how to use your calculator to solve something like that, right? Because the way they want you to do it, it's going to take forever. So let's go to y equals, and let's type in this one for y1. So I'm going to go 40 plus 2x times 30 plus 2x. That's my y1. And then over here, I'm going to put 2,000 as my y2. And now I'm just going to look for the intersection. Now here's the thing you got to worry about, because this is 2,000. And you can see it right now after this like stops thinking. I don't see a thing, right? My window's off. I got to go all the way to 2,000, because I know for sure my graph, there's that graph. This one, who knows what that looks like? It's probably a parabola. It looks something like this. But this one, I know it's all the way up here at 2,000. So I gotta make sure my window can see that. So I'm gonna go to my window. I'm gonna go, my X max probably put something a little bit bigger than 2,000, right? 2,500. And then graph. So now I could, oh, there's that part of the graph. And that's where 2,000 is. Now, I can't see the whole graph. I'm thinking maybe if I went to negative 10, see if I can see better the whole graph. Ooh, no. Anyway, so what's going on is this. You could kind of see this part right here. And right now I could find this one. I can't find this one, but honestly it doesn't matter. You know why? That's negative. right? You can't have a negative width, so the only one I really care about is this one anyway, so that's all I gotta find. And remember on your calculator, the way you find that, just find the intersection. Second calculator, find the intersection, number 5. Just get a little closer to it. Hit first curve, yeah, it counts. Second curve is down, yeah. Guess, please. And you get 5. That works out nicely. So width's gonna be 5. Again, the way they would want you to do it was multiply this all out, set equal to 0, and then factor it. It's going to get ugly, but that's the way you can do it in your calculator. Don't forget to just fix the window. That's the key there. And if you want to put your window back, just put zoom standard, number 6. Now you're back to negative 1010. Anyway, that's the lesson.